Hello everyone and welcome to Mind for Physics. This video will be solving a moderately difficult vector problem. So if you solve this one, you should feel pretty good about yourself. So here you're given that the person moves in 3 different directions and you're given the magnitude of each displacement vector. You're given 25 and the direction as well as direction, which is 70 in the first case, 55 and 15. And all of these angles are given in relation to different directions. So you have to be careful to make sure that you put this in this form, this word problem in this form in an accurate way, right? So this one is already giving you a little bit help because you know that there are 3 components, 3 vectors, and you'll have to add these 3, and the 4th one will be the resultant vector. They're asking you how far is the person from where they started, so they're asking you displacement vector. Obviously, it's in your best interest that you put origin and 0, so you have this person start its journey from the origin, so things are slightly easier for you, and you set this up like so. And as you see here, 70 degrees is not taken from the same direction as 55 or 15, right? So yeah, 70 is taken from the positive x direction, 15 is taken from negative x direction, and 55 is taken from positive y direction. So that's drawing this is basically pretty much 50% of solving this problem. They're asking you to find magnitude of the displacement vector, which is this yellow vector, which you're going to get after you add red to green and all of that to blue, and then you're going to find the resultant vector, the magnitude of it. You have enough information here to find the direction of that yellow vector as well, but this problem is only asking you to find the magnitude. So let's get started. Okay, so welcome to my notebook. I'm going to solve this problem here and show you how you can solve it really easily. So the first vector, I'm going to use same colors as in the slideshow. So 45 is right here, right? So this will be 45 and 45. I have 70 degrees north of east. So this one is north. This is north, and this is east. So north of east is somewhere here, and I'm given 70, right? 70 degrees north of east. Let's say that this is 25 in length. I'm going to try to do my best to keep magnitudes accurate so that the final vector I'm going to get will be somewhat accurate, then drawn to scale. So this is 70, and the magnitude of this red vector is 25. Now I'm going to draw 40 meters in direction of 55 west of north. So if this is north, west of north is this way, and 55 that way. But we were here. So I'm going to draw, because I know that this direction is in relation to north, I'm going to draw a little helper line, here to help me see that this would be 45, this would be 55. 40, maybe that's too long, somewhere here. So this is 40, let's say, and this is 55 degrees. And the final vector is 20 meters in direction 15 of south. So 15, this is west, this is south. 15 south of west is this, okay? But I have to draw here a little bit flatter, I think. Oh. Okay. So what happened? Everything got moved. Okay. This is 20. This is 20. And again, I will draw this helper reference line that I know that this 15, this angle is in relation to this horizontal line because it is south of west. So west is this way, south that way. South is down, right? So by the way, obviously this is y and this is x. So now I need to draw what they're asking me. What they're asking me is how far is the person from where they started. They started right here and they are right here. And how far, that is this vector. They're asking me displacement. So they're asking me how basically what they're asking me to do is add this vector to this vector to this vector, and then find this magnitude of this vector, or find the components of this resultant vector, resultant Rx and resultant vectors Ry. Ry would be here, not X, and then try to find magnitude from these two sides. So I can find this and I can find that. And then I can find this resultant vector. So I'm going to show you how you can solve this problem. So we are basically finding Rx, so X component of this vector, which would be this vector. Okay? And Y component, which you can draw here. This would be Ry, or you can draw it the same exact vector of same direction, same magnitude. You can draw it here. This would be Ry. This would be Rx. That's what I'm trying to find. So Rx, okay? First, I'm going to concentrate resolving this red vector. It's going to have X component, which will be this one. It's going to have Y component, which will be this one. So I'm going to resolve that, and its X component will be 25 times cos of 70, because cos theta equals to adjacent over hypotenuse, right? And therefore adjacent equals to hypotenuse times cos theta. Sine theta would equal to opposite. It would be this one, okay? That's just a refresher for you. I don't know who needed that, but there it goes. Ry. Again, trying to still resolve this red vector. This will be sine of 70 degrees, right? This vector would be, this side would be opposite. So that's why I need sine function. Okay, I'm done resolving. There is no third dimension, so we only need x and y. I'm done resolving this red vector. Moving on to green vector. Here, I need to think. With red vector, I was in first quadrant. But with green vector, I know that its y component will be positive. This will be positive because first and second quadrant, y is positive, x is going to be negative in the second quadrant and third quadrant, right? So its x is going to be negative right here, but its y is going to be positive. I'm going to write negative here because I need to keep that in mind. Now this is the x component of this green vector, or this is the x component of green vector. However, you can see it better, but they're the same. And this is the y component. As you can see, this is the angle. And now x component is not going to cos function. So you can't remember that x component of a vector is always cosine. Usually it is when you do Newtonian mechanics. Usually if something is sliding down, it's going to be mg cos, because this will be x. But a lot of times they can test you and show you and test you if you know that this would be opposite. So this is going to be sine. Okay, so this will be 40 times sine 55. And this y component of this green vector, green y, is going to be cos function. So, and positive, because as we discussed, this is positive in first and second quadrant. I'm going to erase this so that I don't have too much stuff going on. As it is, this picture is too much stuff going on. Now I have to resolve this final blue vector. This blue vector is basically, you can move a vector in parallel. You can, as long as you maintain its direction and its length, you can move it anywhere pretty much. So you can see here that its x component will be negative and its y component will be negative. So I have to put down minus sign in front of both of these. So finding its x component, this one is x component, right? So it will be adjacent to this angle. It's actually touching. That's how you know it's adjacent. So I need cos function. So I need 20 times cos of 15. And its y component will be, it's this ETBT vector. It will be minus 20 sine of 15 degrees. And that's it. Now I just need to put all of this in the calculator, find my resultant vectors Rx, x component, and y component, okay? And that's it. This is minus 43.5. I've already done this. So I know. And this is 41.25. Oh, not degrees, obviously. These are lengths. These are meters. So negative meters sounds horrible. Obviously, this negative sign is only here to show you direction. So positive x is this way, and negative 43 would be pointing this way, because all of these are vectors. This will have direction. So minus sign obviously is trying to tell you something about the direction, not length. Length can never be negative. So this vector, length of it is 43. And it's pointing in the negative x direction because my positive x direction was this one. So then this vector is, the length of it is 41.25, and it is pointing in the same direction as my positive y direction. So it's positive. But that's not what they were asking me. They were not asking me to find the component of the resultant vector. They were asking me to find how far is the person from where they started. They started here, and they are right here. So this is how far they are from where they started. This is their displacement. So I need to find this vector. So at this point, you have boiled this problem down to the final step, which is finding the hypotenuse of this right triangle. And the way that you do that is r equals to square root of, this is Pythagorean theorem or Pythagoras theorem, and you square both sides and you add them, take square root, and you are done. So don't worry about minuses here. This one has minus. Don't worry about that, because once you square a number, it's going to be positive always. 41.25 squared. And that is 59.9. So that is basically 60. Now I'm going to show you how you can solve this problem. The same problem, right? I'm going to show you how to solve the same problem without having to think about these minus signs. So that there is a way that basically takes care of these minus signs so that you can kind of blindly go through the problem. But there's one adjustment that you have to make. So instead of using these angles and then thinking about which in relation to what this angle is, you have to kind of stick to a convention, which is to take the angle from positive x direction. So every angle will be taken from this side. With this red vector, things are going to be exactly the same. So let's start over, basically. exactly the same. So here, nothing has changed. But with the green vector, things will change. So now you need this angle. You need not this angle, but you need from positive x direction, which is right here. So you draw another line, and then this angle, you know, is 90. So 90 plus 55 is going to be that whole angle, which is 145. This will be 145. Okay, so now you're finding this side, and the way you're going to do it is basically 40 plus, you don't put down minuses because that's going to take care of itself. 40 times cos of, here x's are going to be cos functions here, and of 140, did we say? 45, 90 plus 55, yeah. So that's going to take care of the minus sign. In fact, if I put it in 40 times cos of 145, that equals to minus 32.7. So that minus sign got introduced because your calculator knows that cos of 145 is indeed negative, so you don't have to think about it. Now putting down this vector, again, putting plus, I'm not thinking about pluses or minus. This way it's bulletproof as long as you do the angles right. Here, this is 180 plus 15. So I'm going to do 195. So 20 times cos 195. And if you check, cos of 195 is negative 0.96. Because you know that cos of 180 is minus 1, and 15 is really close to that, so it's almost minus 1. Oh, why am I erasing this? So the answer is going to be the same. It's going to be minus 43.5. But you see that you got to it without thinking about these pluses. So, and you can stick with cos functions for x, but you, of course, have to get all the angles in relation to or from the positive x direction. So this 70 was the same, but this 55 was not. We had to add 90. This 15 was not. We had to add 180. So that's the adjustment, but it's easier after you make that adjustment. So ry, of course, this will be the same. So this will be 25 sine 70. Again, this will be green. I need green. Plus 40 sine 145 plus 20 sine 195, and you're going to get the same exact answer, which was 41.25 meters. Of course, you're going to get the same, if you square these and add them, you're going to get the same answer as you got previously. So these have to be the same as well. This is just a different way to do it depending on which one you prefer. Here you have to think every step of the way, and for this one it was x component was sine, not cos. So that's another thing. Here x components are all cos, so whichever you find easiest. I just wanted to give you both ways to do it, and there is no third way to do this type of a problem. This is the way to do it. Thank you for watching. I hope this helped you. Have a great week. Bye.